We've been sampling seagrasses and water quality for about the last 15 years to better understand how nutrients might have a negative impact on the seagrasses and the health of those seagrasses. On a global scale, seagrasses in shallow coastal waters are about 10% of the ocean area, and so they're significant globally, but they're threatened globally as well. And the biggest threat to seagrasses in general is increased nutrient inputs. And the reason is that increased nutrient inputs stimulate algal production. And that algal production can be in the form of phytoplankton in the water column, or it can be in the form of macroalgae that grows on the bottom. And so what happens is increased nutrients in the water column stimulate algal growth, and ultimately that algal growth either leads to decreased light availability for the seagrasses, it smothers them, and ultimately the seagrass goes away. We started seagrass sampling in the late 1990s, and we were doing a lot of sampling actually at that time along the Big Bend coast of Florida. One of the things that we've noticed right away is that over the last 15 years, nitrate, which is one of the principal contaminants in the system, continues to increase in the river systems, and that's been a concern. But what we've also realized over that time is that there are other nutrients that play important roles in the ecology of these systems, and phosphorus is another one. Many of these rivers that discharge into the Gulf of Mexico are spring-fed, and the water that feeds those springs is of a groundwater origin, and that spring-fed water is contaminated in nitrate and ultimately finds its way into the Gulf of Mexico, where it can cause some serious ecological problems. Prior to the oil spill, there was a lot of people that recognized that we needed to do some sampling of the environment before the oil actually arrived on this coast. And there wasn't a lot of data on ongoing sampling programs to be able to do that. In fact, the program that we have is one of very few in existence. And we've been sampling for the last 15 years, and it provides an excellent baseline actually for us to be able to look at any impact should they occur as a consequence of the oil spill. Seagrasses are really important for a lot of reasons actually. As a habitat type or as a plant, they photosynthesize and they provide oxygen. They're among the most productive habitats on the planet. They provide forage habitats and refuge habitats for a number of fishes and invertebrates. And they're critical as nursery habitats for a number of organisms. Beyond that, what they tend to do is, because they're structural elements, they tend to dampen wave energy. And when they do that, they promote the deposition or the settling of particles, which then in turn promotes water clarity. Because they have a lot of below ground biomass in addition to their above ground biomass, they actually stabilize sediments, and in some ways protect the shorelines from erosion due to storms and things like that. They're very important from a carbon perspective because they promote the deposition of particles and detrital materials. A lot of carbon is sequestered in seagrass beds. As a scientist, my goal, particularly within IFAS, is to take the information from the studies that are carried out in my lab and take that information and transfer it into the management arena to better manage the resources that we all enjoy.